Welcome everyone to this session where we will update the progress of the Continuous Integration Working Group of the Academy Software Foundation. We will have a few presentations. I'll go through the proper agenda in a moment once everyone's had a few seconds to land and adjust. As usual, we do have both chat and Q&A in this session. And as a fairly short session, please don't feel that you need to wait until the end to post into the chat or the Q&A. We'll do our best to overlap things as much as possible in order to allow us to make best use of the time. And if we're planning on having a little bit of time at the end, so we'll choose some of the questions that have been upvoted in order to answer those live. The others we'll try and answer in the text box itself. Okay, we have 50. That was our magic number. So we will dive right in. Okay, so today we'll give a quick update on what it is that we're trying to do with CI in the working group and for the Academy Software Foundation in general, with, of course, a short note to explain how these efforts relate to the VFX Reference Platform. JF will be giving a bit of a background and also highlighting the current entry points in order to understand and redeploy the CI system for other needs. Aloys will be giving an overview of the Docker infrastructure that we're using to provide repeatable and efficient configuration and environments for our CI needs. Christina will be giving us a case study example of how the CI system is being in use for one of our projects, OpenEXR, and then we'll be going back to JF to discuss some of the active challenges that we're working on within the working group, and that is definitely a hook for involvement from any of you or others that you may know who have interest or expertise in these challenging areas. And lastly, of course, we'll have some time for discussion. Okay, so as we move through, you will hear from each of these people and hopefully see them on your screen. And obviously they can each introduce themselves as they go. My name is Daniel Heckenberg. I'm an R&D supervisor at Animal Logic, and I also serve as the chair of the ASWF Technical Advisory Committee, and I've also been chairing the CI working group. Contact details, of course, these are available elsewhere, but if you'd like to take the moment now just to find the Slack channel in particular, and we'll have this slide at the end, of course, of the session as well. Great. So the CI infrastructure that we have developed was an attempt to provide modern CI infrastructure that would work well in an open source setting, using primarily sort of GitHub as the core of our as our open source control model. This has undergone a number of evolutions, and JF will talk to those in a moment, but our goals were not only to serve our projects very well, but also to really make it easy and encourage best practice as a start. So extending our use of CI to things like static analysis and so on. And secondly, also extending, making an infrastructure that would make it easy for other projects and other open source endeavors in order to pick up parts of, open source and proprietary studio endeavors to pick up parts of the system that we were developing and reuse those in other contexts. And we'll be able to see how that's come about, particularly through the evolution of the architecture that we're using. So a word about the VFX Reference Platform. Those of you who've been involved in software development in our industry will know that the particular mix of commercial binary components and large amounts of open source and proprietary in-house software create a particular challenge for integration and version management. The VFX Reference Platform obviously was an attempt to coordinate changes and testing of all of those different combinations in order to provide a much narrower matrix of configurations. And we are of course using that as the embodiment of our build configuration environment. Aloys will talk a lot about how we're actually taking essentially the specifications that the VFX Reference Platform provides and turning those into concrete recipes, which we then use to build Docker containers, which can be used by our projects or for other purposes. And indeed, we're doing that not only now for current and historical versions of the reference platform, but it also allows us to do testing for new and current versions as the various components are developed. There'll be another session specifically talking about the VFX Reference Platform as part of Open Source Days happening tomorrow. So please join in there for more details. And with that, we'll move over to, just lost control. Good. Sorry, we're just having a mouse tussle. And with that, we'll move over to JF, all yours.
Yes, the remote control is not working. Oh, there we go. Just there's a delay. Okay, so when the Academy Software Foundation was first set up, CI was identified as one of the initial deliverables. And the initial implementation was based on a reference design that the Linux Foundation had used for some of its other some of the other foundations that it had helped put in place. So this was a, and I am on the wrong slide. If anybody, oops. Is there any way that somebody could try to control this and move it backwards for me?
Yes, I'll step in. There we go.
There we go. Okay. So the system was still using GitHub and Git for source code management, but all other components were open source and were hosted on a OpenStack cloud provider. And and then the system for managing everything was based on Jenkins, and then a set of predefined VMs would host Jenkins, Linux and Windows builders, Nexus for artifact storage, and then SonarCloud for static analysis. It turns out that it didn't work all that well for our needs. It was somewhat Java-centric because it had been really put in place for Java-based projects. So it didn't work as well for our mostly C++ and Python projects. And also it did not, the support for Windows was really not quite there yet, and it did not support Mac. So we then moved on to a system fully based on GitHub and Azure pipelines. And the integration, the interest of Azure pipelines is that it offered a modern YAML-based pipeline, so you could define your CI steps in a YAML file that was controlled as part of your source. And it also offered free builders for Linux, Windows, and Mac, which was a great attraction, and meant that our projects no longer had to have different CIs to cover different platforms. It also supported built-in container workflows on Linux and Windows. And it had a number of third-party integrations. And we also, at that point, we also moved to using the SaaS-based SonarCloud for static analysis. But then GitHub, basically Azure Pipelines kind of, in a way, although it is still offered, morphed into GitHub Actions. And GitHub Actions having kind of instantly so much mind share in the open source community, we decided to transition to GitHub Actions. Not having a separate CI system from the SCM system meant fewer moving parts. It allowed us to do things like fairly simply share organizational level secrets. So for instance, a single token for SonarCloud analysis or a single token for GitHub, pushing to Docker repositories could be shared across all of our projects. It does offer Linux, Windows, and Mac builders. And as I said earlier, it has the widest open source developer mindshare. A couple of things that came up during the keynote session is the desire to have a build infrastructure or a CI infrastructure that is reproducible by studios. You cannot, basically, it is felt that GitHub at this point is sufficiently well known, and even private GitHub instances are used by multiple studios, that it really should, and similarly, there are private versions of external services like SonarCloud that you could basically use the same infrastructure for building, for either a private build of an ASWF project or your own builds. And then I also wanted to point out that we have a reference project or a sample project in the ASWF GitHub repo, which is meant to capture kind of the best practices and where the what projects are agreeing to in terms of developer infrastructure. So it's kind of a developer-centric piece of documentation, if you want. So everybody who's interested is encouraged to take a look and to contribute. And that's it for me. So on to Aloys.
Hi, my name is Aloys Baillet. I'm a development lead at Animal Logic, and I've been involved with the ASWF for about a bit more than a year now, year and a half. We started using Docker at Animal Logic and in my personal time a few years ago now, and it felt like a good fit for the ASWF needs in terms of trying to have a platform that would be consistent and flexible enough to run unit test builds for many of the VFX platform packages. One thing, the main benefits we found with the Docker-based approach that we used was mostly the speed. When we run the test at the moment, in some of the platforms, you still have to build Boost, you still have to build some of the upstream dependencies before you can start building, let's say, OpenEXR or some of the other packages, and then running the test. So you lose a lot of time before you know if you've broken something in your builds. So Docker allows you, as a very lightweight virtual machine, to have the same environment on the at home, on the cloud, and to know exactly how your tests are going to run. So trying to scroll down. Thank you. So over the years, we've created a VFX platform 2018, which was the new GCC 6. We've added 2019 with the new Qt, 2020 with Python 3. The making of the images for the year 2020 were quite interesting because it was early on when not all packages had Python 3 were not quite compatible yet. But it was a great place for people to actually try and make sure that they had a Python 3 environment working. And a few months ago, we started with a 2021 VFX year, which is a brand new compiler with new C++ standard. So these images have been able to allow all the different teams working on different packages to really test the new compilers and make sure that they didn't break the old ones. So if you go on the homepage of the ASWF Docker GitHub repository, you will see in the README all the various images that we have. So I don't know why the arrow. So I wanted to have a quick recap on how much the images were used. So I ran some stats, and it's been quite popular. OpenVDB, thanks to Dan Bailey, was one of the first clients of ASWF Docker images. It's now clocking at 21,000 Docker pools. OpenColor.io was quite an early adopter as well. OpenEXR, Christina will talk about that a bit more. Open Shading Language has started using this just a few months ago. OpenQ was there as well. We have pushed about 220 gigabytes of Docker images in the cloud. That it's a non-negligible amount of data when you think about it. It's the biggest packages are Qt, Clang. They're all hundreds of megabytes each, or more than a gigabyte for Clang. So it takes a while to upload, but the download on the cloud is very quick. So it's still faster to download a gigabyte of Docker images than to rebuild some of these packages like Qt. We maintain actively about 45 CI images. So that's a combination of all the VFX years and the different packages that you have here. And we have 85 intermediary packages like Qt itself, like Clang, OpenEXR, etc., that are also maintained on the side and used. So I'll go to the next slide slowly. One of the things we're starting to work on is a set of runtime Docker images. So the Docker images that are used by the CI system are geared towards building software, and they have a lot of compilers, a lot of headers. We can actually build slimmer images for just runtime. And that's something we started to experiment with the USD working group to be able to run USD on the cloud inside Jupyter notebooks, for example. And we're also investigating how we can make GPU work in those Docker images on the cloud. You can make it work locally on your workstation quite easily, but on the cloud is a different problem altogether. So one of the things that we're going to focus on now is how we go to provide this kind of convenience on Windows and Mac, where containers are not as not as refined. The experience is quite rough to build containers for Windows, and Mac does not actually support Mac OS Docker images. In order to achieve that, my hunch is that we'll need to figure out a package manager to build our packages and to download them quickly. We'll still keep the Docker convenience for Linux, obviously, where we can, but in order to replicate the ease of use for CI use cases, I think we'll have to start building smaller packages. And I'll leave now to Christina.
Hi, so I'm Christina Tempelaar-Lietz. I'm a software engineer at Epic Games, and I'm also on the TSC for OpenEXR. And I'm going to talk about continuous integration and how we use it in OpenEXR. So our OpenEXR CI consists of 2 GitHub Actions workflows. We have a CI workflow that is, we call it the CI workflow, which is a multi-platform, multi-configuration set of build jobs, which are invoked upon pull request and push. And then we also have an analysis workflow that's a variety of slower running jobs that are scheduled to run weekly. They perform analysis on the library and give us feedback like potential security vulnerabilities or potential memory issues and so forth. These workflow files are described in the repository in a directory called .github workflows, and the name of the 2 YAML files you'll see listed here. And let's see, do I have control to go to the next slide? Oh, thank you. So this is what you'll see when you issue a pull request to OpenEXR. You'll see there's a section in the pull request for checks, and it checks things like such that you've signed off on your submission, and that you have or signed off on your commit, and that you've assigned a CLA. And then now you'll also see a series of builds get kicked off, which are a bunch of different permutations of different configurations of operating system, different compilers, different VFX reference platforms. And these will all initially show a small yellow circle to the left of the job that indicates it's running. And once they've completed, they'll either have a little green check mark or a little red X indicating whether it's passed or failed. If your job does fail, you can click on the details link to the right, and that will take you to the output logs to give you an indication of why it failed. If someone could advance to the next slide. Thank you. And then this is what the logs look like. You can also get to these logs by clicking on the Actions tab at the top. And if you click on if you come to them via the Actions tab, you'll have to drill down into the CI to find your particular run of the workflow. And then once you click on that, you'll see the list of jobs on the left. And then selecting a job brings up the logs for that job. And within the logs, you'll see a bunch of steps for that job. And then to the left of the step, there's a little caret that you can twirl open to see the log output for that particular job to give you some indication of why the particular job failed. Sometimes they'll fail and have absolutely nothing to do with your pull request. Sometimes the checkout fails, it freezes up, or the node entirely freezes up and doesn't run anything. And in that case, on the upper right here, you can select to rerun all jobs. There isn't an option to rerun just a single job, but usually if you just rerun all jobs, it runs everything, and usually it clears up any issues like a frozen node. That doesn't happen too frequently. The next slide. So now I'm going to talk briefly about what's in our analysis jobs and our analysis workflow that runs weekly. We have a SonarCloud scan that performs static analysis, and it's configured to also run coverage analysis. We have a Valgrind memcheck job, and then we have OpenEXR's own fuzz test, IMF fuzz test. Next slide. And this is what the SonarCloud scan looks like. The SonarCloud scan performs static analysis on both compiled and source code, and it also is configured to run coverage analysis. And this is what the SonarCloud project page looks like for OpenEXR. Basically, there's a lot of information that you get back from the scan. It reports potential bugs, potential security vulnerabilities, code smells. It gives you an indication of how well the library's code is covered by the tests in the library. The URL is at the top there. And there's a lot of interesting information in here, a lot of historical metrics, a lot of just fun things to drill into. So I encourage people to go look at this project page and poke around it. And I think there's a lot of fun information in there. Next slide. And then, as I said, we also have a Valgrind memcheck job. This profiles and debugs the library, detecting memory leaks and errors, things like uninitialized memory or arrays out of bounds array access. And then we have OpenEXR's own fuzz test, IMF fuzz test. This is runs its own fuzzing engine to damage EXR image files, and then attempts to read them back in and see how resilient the library is, see if it produces any failing assertions or any if there's any potential memory leaks or potential crashes. And then I also want to mention that external to our CI, we're also now monitored by Google OSS Fuzz project, which is an online fuzzing tool, and that performs combines a bunch of different fuzzing engines with a bunch of different sanitizers, and then reports back to us potential security vulnerabilities or potential stability issues that we can then address. And next slide. And then I also want to point out that in the README file, which you would have seen also in the Docker README file, there's a set of widgets here at the top, and they show the current status of the latest run of the CI workflow, the latest run of the analysis workflow, as well as the status of the latest SonarCloud scan. These are also links, so they're kind of convenient for being able to get to that SonarCloud project page if you don't want to go look for that long URL. And it also, if you click on the CI and analysis, those links will take you to the logs for the latest runs of those workflows. Next slide. And then lastly, I just want to acknowledge Michael Dolan of Epic Games, who developed OpenColor.io CI, and then Dan Baillet of ILM, who developed OpenVDB CI. I leveraged their work heavily in developing OpenEXR CI. And you'll see, if you look at the CI of the different ASWF projects, there's a lot of commonality. So knowing this kind of overview, you probably would be comfortable looking at CI for the other projects. Thank you. And now I'll pass it back to JF.
Perfect, thank you. And I did want to, while we're mentioning thanks to, of course, include a big thank you to the Linux Foundation release engineering team who provide underlying support for all of the infrastructure and expertise from other projects are associated with. Jeff?
So, okay, next slide, please. So a very specific need that our some of our projects have is the ability to run OpenGL workloads during the testing phase. And not only OpenGL, but actually hardware accelerated OpenGL in order to do conformance and exactness testing. In particular, OCIO has both GPU and CPU paths and needs to verify those. So that's proven to be quite a challenge to provide this, because free runners provided for open source in open source CI systems typically do not have GPUs. And systems that do have GPUs, such as AWS Code Builder, typically target CUDA applications, not OpenGL applications that need an X server. There's a tease from one of the GitHub roadmap issues that there may be an offering with GPU accelerated builders at some point in the future, but that is currently not available. Next slide, please. So one of the attempts that we tried was to try to stand up builders on the fly with Terraform. And there's a number of requirements that were found. You need the NVIDIA Grid driver that provides hardware accelerated OpenGL. You need an X server. You need to start your container with very specific command line increments. So right now we have a prototype, but we have not been able to productize that yet and deliver that functionality. And we're looking at other options, such as using libraries such as EGL that avoid the need for an X server and allow applications to speak directly to the GPU without requiring external machinery. We're very much hoping to have a final solution in the next few weeks. Next slide, please. And then the other big deliverable is support for Windows and Mac builds. And what's interesting there is the VFX Reference Platform is now starting to specify baselines of compiler and OS versions for those platforms. And that is what we're going to be targeting. For now, we don't think that we will be able to use the container, well, especially as there is no container support on macOS except for the MaxDaemon Orca offering. But there are enough package managers that support those platforms that we should be able to make it work. And that's it for me.
Great, thank you. We've managed to get through a lot of content and unfortunately not much time for discussion, but that is an excellent hook for to draw all of you into further discussion on the Slack channel, where we have all the time in the world, of course. Thanks again for all the presenters and for all the work that others in the working group have done over the last year.